Dancing Griffith's occasional series of Matlab tutorials in YouTube. Today we'll be looking at Friedman's test, which is a very simple test once you know what you're doing. And we're looking at this particular data set here. So we have car column A, car column B, and car column C. We want to see, are they the same? So treatment A, treatment B, treatment C, are they the same? And we look at the notes in more depth. We cannot test for the blocks, rows A, B, C, D, E, and F. We can only do the columns for Friedman. So if we just go up to here and we just maximize my editor. So when you're doing a normal two-way ANOVA, lines 5, 6, 7, 8, or 9 are there. That is independent. That is normally distributed. The variances are the same amongst each groups, and the covariance is homogeneous. If any one of those or more fail, you'd have to use an equivalent non-parametric test, and the non-parametric test for comparing 3 or more groups is Friedman's test. So just to say, lines 14, 15, 16, 17, 18, 19, or 20 are taken from the Matlab help file. And we're just going to carry on with that. And repeating myself there again, they may have a two-way layout, but you can only treat the columns. Okay, so you can't treat the rows. And if you did want to treat the rows, you'd have to transpose the matrix and do it that way, but that's just getting a bit advanced. So line 28 and line 29, you cannot test for possible row differences. There's the command load mileage, so you load the pre-built or inbuilt mileage.mat dataset, and there's the line. You call the Friedman function on the dataset mileage, and there's 3 columns, and P is the returned probability value. As per normal, HO is that there is no difference between the 3 groups, and HA is you assume that there's at least a difference, at least one of the 3 means are not the same. We have some comments there, but just look at that before we do that. So have that. Let's just run it because I've killed the figure. So there's the data. The figure is a little small. If I get my magnifier up, I can now just go over here a sec. So we can read it there. So there's the probability it returns 0.0007, so less than 1 in 1,000. Normally you would test at 5%. So if the return probability is 0.05 or bigger, you would accept the null hypothesis. What's the null hypothesis? The 3 means are the same. If the return probability is less than 0.05, we have reason to reject the null hypothesis. So in this particular example here, the return probability is 0.0007, so that is less than 0.1%. So we have very strong reason to reject H0. In other words, we think that at least one of the 3 columns differ, at least one of the 3 MPGs differ. Hope that helps. Thanks very much for listening.